Our first talk is going to be on unmanned aerial vehicles, which is something that's coming in. A few of you may have seen these in action or heard about them, but most of the people here, especially the designs and drainage people, wouldn't realise what they're up to these days. So we're going to start off with unmanned vehicles, aerial vehicles. And Matt Thomas from Position & Partners is going to give this presentation.
Thanks very much, Lee. Great to be here today. Look, UAVs excite me, so if I sort of get a little bit excited, please try and calm me down a little bit. But I'm a bit more excited about our guest speaker later. He sounds fantastic, so I don't think these little UAVs will be quite as exciting as that. But anyway, let's see how we go. So UAS or UAVs, essentially they're for lots of different geospatial applications. So we've got a few pictures up there of different applications. So in farming, we also use them in mining or in quarries, and also can be used in some civil type areas. So a little bit about the session. So about Position Partners, about UASs, a little description on what they actually are. Also the market drivers, why are we starting to use these? Geospatial applications. I mean, I showed a few photos there, but I'll go into a little bit more depth. The value, why would you use it? And also a couple of case studies on where we've actually used these. So a little bit about Position Partners. Who are we? Well, we like to consider ourselves as Australia's premier provider of positioning and machine control solutions, for land management, also for civil works, and also for building activities. So in 2008, Position Partners was established. It was a result of our customers asking for national support and national service. So we're a bunch of individual companies which actually came together. So now we're a nationally structured team. We have technical sales representatives. We have people in the executive side, and we also have support and administration people. The idea is for us to be a national company, but also to support on a local level. We also, with this joining together of making one large company, we looked at other ways in which we could grow our business. And all businesses, if we don't grow them, we go backwards. So the idea was to bring on some new initiatives. And one of the ones we saw was these UASs or UAVs. And we saw them, we realised that this is something that Australia needs to capture. So we took it on. We employed someone who actually has a pilot's degree. And he actually has his licence, and he has been working with us and looking at all the different options that are out there. So throughout the time that we've taken them on, we've seen lots of changes. So what are the market drivers? So the geo information market, it's growing at a very fast pace, and we want to get some information at a real timely manner, and we also need the accuracy at the same time. Now, this technology has been proven in the military, so the military has said, okay, this is good, and we now are starting to use it in civilian applications. So you'll see a couple of little pictures there of someone utilising a UAV for civilian use and someone using it in military. And they're both very, very different UASs. Also, another thing that's changing in Australia is the regulations that CASA have. So there were very restrictive regulations a few years ago. At the moment, they're spending time rewriting these regulations so that there is airspace up there for us to be able to use these for our aerial surveys. Now, there's been a proliferation of these units. There's lots of different types, and they work differently. And it's like a hammer. There's a different tool or a different hammer for every job. You don't use a sledgehammer to hammer a nail in. So when you look at the different UASs, you can look across the market. You can say, okay, well, there's one that's great for that small job, for that quarry that's close to the houses, or there's one that's fantastic for that large mine site out in the middle of nowhere. Also, it might be a windy day. What do we use on a windy day? That small unit we have gets blown about and our results are no good. So you really need a couple of different units to be able to cover the spectrum of the jobs that are happening out there in the marketplace. So you'll see here, there's a lot that are like helicopters or using copters, hexacopters. This one here actually has a bumper on the outside, so it can bump into things and it won't break. Some of the ones like this particular one here, you've got to be careful with the rotors. This one here, is designed for long distance, etc. So, there is quite a varied number of different types of UASs. So, the geospatial applications for this. So, I guess the question is, who can use these? Now, mining and resources have plenty of different applications. If you look up there, stockpiles and waste dumps. Things like environmental assessment, impact studies, accident and emergency, assets and infrastructure, and exploration and mine mapping. Those large open areas, they can fly a lot and they can pick up a lot of information. Civil design and construction. So for linear infrastructure, for selection, planning and monitoring. Earthworks, doing volume calculations, and for progress reporting on your jobs. Environment and biodiversity, mapping your wetlands, your vegetation, your animals, your habitats. Forestry, having a look at trees, working out the health of your trees, of your crops, your water, your nutrient, that's your pesticide, all that sort of planning that goes into place when you're actually working in that industry. And also your harvest planning. Your emergency services, your natural disaster response, your accident, your incident, your crime scenes, fire monitoring, defence and customs, and being able to target certain areas, doing terrain intelligence and surveillance. And research, things like archaeology, heritage and geology. So why use this type of technology? Well, it's more affordable than normal manned surveys. So those manned surveys, those planes cost a lot of money to put up. It also, one of the other things that I haven't mentioned here is on a cloudy day, those high surveys, you generally can't fly them. But because you fly below the clouds most of the time, these actually work. On site, having these equipment in your toolkit means that you can actually deploy them when you want to. So you can get information at different stages throughout the job instead of waiting for the right day and having a flyover. It's much more cost effective. And also, it says there emergency response. So if there's a bushfire and we want to go out and we want to have a look at where the fire breaks are, etc., we can send a unit up straight away. So there's minimal field acquisition time, and that frees up our survey resources as well. We have the absolute control of the routine and the hot flyovers. And we can sort of get the results quickly by doing it in a timely manner and having a quick response. So here we've just got a flow of the workflow in which we would actually have. So we set up our unit on the ground. We have a communication device, and we generally have communication between our UAV. Now we can control them via a joystick, or we can preset their course. So we could preset their course with a GPS map, and they will actually fly that course. If we want them to divert their course, we can control them via radio and say divert. If we want to control them the whole time, we can also control them the whole time. But CASA seem quite happy with us actually presetting a course for them because there's less chance of making errors. So you'll see quite often that that's the way that things are starting to go. So here we have one of those hexacopters. We have a fixed wing aircraft. So yeah, we have our communication, our mission control or controller on the ground. We do our flight checks. We then take off. We fly. And in most of the situations at the moment, we're finding that the payload that we can carry is actually quite small, so the payload we're carrying is generally a fixed focal length camera. So in these two, you'll see fixed focal length cameras, one hidden in the body here and one below the unit. So they'll go out and they'll take high-res images, 1 kilometre by 1 kilometre site, you might get 450 images, for instance. And then what we'll do, we'll capture those images and then we'll do some processing. And the processing of those images, we'll also put some ground control. So once we've done that, we can then get DTMs out, and then from that, we can go through and do some image analysis and post-processing. So just a couple of case studies. So a couple of times we've used these units in real-time jobs, and this was actually a road that was in New South Wales. So the area that we wanted to fly over was 2 kilometres by 400 metres. There was control, so there were 6 control points within this area, and it was a road reserve. The day had some broken cloud. There were 25 kilometre-an-hour winds, and we actually took 495 photos, and it took us 30 minutes to fly it. So the time up there wasn't a lot. So from this, we actually got a whole heap of photos, ortho photos, at 5 centimetres. We also got DSM. We also got point cloud, which was non-colorised, of 12 million points. And we also had a whole other heap of formats that we got out of this particular processing. And we also got a reconstruction report, which I'll show you. So on the reconstruction report, we ended up with our bundle adjustment here, and you can see there's a number of different errors. So errors in your easting, your northing, and your height. So when we put them all together and we work out our mean, you'll see that there wasn't a lot of difference. Also, when we actually go and overlay our imagery, you'll see here, these are our differences. Now, one of our control points, of which we had 6, one of the control points was actually outside the road reserve. So it was outside of the image that we actually picked up. So that's why you won't see any residuals there. So when we then go and analyse our strings that we had across the road, this road reserve had actually already been surveyed, and so we're just having a look at the difference between the survey we'd done conventionally and a survey that was done aerially. So we actually had 13 strings across the road. And if you have a look at those 13 strings, there was an average difference of 0.047 of a metre. Now, if we actually drill down into the data and have a look, the 4th string was pretty bad accuracy. So we can't just look at that and say, hey, why is it so bad? We drill down, we have a look and say, okay, well, the reason it's bad is if we look closely at it, there was actually a tree overhanging it. And when the tree was overhanging it, it was obviously picking that up. So there was 800 mil there of error. And then we could ascertain that that was the issue. So once we then removed that as being an issue, we got it down to 0.025 of a metre. So nice tight accuracy for a quick flyover. So people say, okay, well, it's half an hour in flyover. What were the other times? So your project planning in the office was half an hour. We're looking at establishing and marking our control of an hour. Our pre-flight was half an hour. Our flight was half an hour. Our post-flight was 25 minutes. Our post-processing that was manned was 25 minutes. Our post-processing that was just done purely by the machine, where we weren't there anymore, it was just crunching away, was 4 hours. So there was a total of 7 hours, but of that there were only 3 person hours involved in this. So quite quick for the type of result that we got. So just a little summary in that for the road survey. Look, it is less accurate than RTK or a total station, but it's a low-cost, rapid way of picking up your data and processing it. And as you can see there, when we actually removed our outliers, we were able to get the difference down to be quite tight. So what are the potentials? So I guess in areas where you can't manage the traffic, it's a nice, useful way of doing a pickup. It's suitable for as constructed feed and pre-tender surveys, and also subject to further analysis and testing by the industry. I guess we need to see whether there's full acceptance there by the roads authorities. But this is one job that we did just to show what we could get out of it. So here's another study that we did of a quarry. Now, this particular quarry, you'll notice that we actually fly over a slightly larger area than the area that the quarry actually takes up. And this is to make sure that we get all the outliers. So we flew an area of 1 kilometre by 600 metres. We took 408 images. We had 10 ground control points. Now you might say that's a lot, and we certainly don't need that many. But the reason we had 10 was because we were actually going to compare it to some scan data that we actually had on that particular site. So it was a 30-minute flight, and we ended up, as I said, the actual site itself, let me just go again, the site itself was slightly smaller than the area we flew. So here's the control points that we had around. There's actually two here really close together. We actually threw one of those points out because it was quite inaccurate. So if you have a look at the residuals on the control, you'll see that we're pretty close with the imagery across all of these. Now, if we were to compare the two methods that we'd use to pick up this quarry, you'll notice that we've got two acquisition methods. We've got one with the UAS, and we've got one with a terrestrial scan. Now, we have a lot of points once we've got this down to a 1 metre grid in our UAS. So you'll see that there's 181,776 points there. Our volume is 6.5 million cubic metres. Now, or 6.5 million, or just over, I should say, whereas this one here is just under when it's been picked up with a terrestrial scanner. A lot less points, but the difference is only 70,000 cubic metres. So we've got less than 1%. So it's a really quick way of getting your volumes. And we can do that and get it extremely accurately. So what's right? Is the laser scan right? Is that right? Well, the laser scan's probably closer, but for the amount of volume that you get in a very short time, this is a really, really good way of doing it. So this job, it took 1 hour in planning, 1.5 hours to get the control and targeting set up. Pre-flight was half an hour. The flight was 1.5 hours. Sorry, was half an hour. Post-flight was 1.5 hours. 6 hours of processing, unmanned, and 2.5 hours to do your quality checks and volume calculations. So, and that's pretty much it. That's what I was going to show on the UAS. It is just a very brief overview. If anyone has any questions on this, please feel free to ask me after the break. We do have Darren, our pilot, who couldn't make it from WA, so I'd be happy to be a conduit, and if there's any questions I can't particularly ask, to go through them with Darren. So, yeah, thank you very much. Okay, thanks.